This video will cover R's special value for missing data, which is NA. The R code and data used in this video are available on the Learning Management System. You'll need the data file weatherwithnas.rds. You should download those files now if you'd like to follow along. By the end of this video, you should know what an NA value is, what data types in R support NA values, how you create NA values in R, how R deals with NA values in calculations and logical tests, and how you can test for NA values in R. R has a special value to represent missing or non-existent data. It is represented as NA. NA is special in that R will always interpret it to mean the data are missing. Every R data type allows for NA values. You create an NA value in R by typing the letters NA. This is not text, so you don't use quotes. So in this example that I have here in the slide, you just type the letters NA into R, and it will return the missing value. This is very different from typing NA inside quotation marks, which is text representing the letters N and A. We'll look at this in R, but first we'll run my setup code. The letters NA denote the missing value in R. If you just type NA into the console, you'll see the result is the missing value NA. This is different from the text NA, which would be in quotation marks. I'll type that into the console. You can see that's quite different. I get NA inside quotation marks. Only NA values outside of quotation marks are missing values. NA values denote missing or unknown information. They're still data, but they're recording the state of your lack of knowledge. So this means they still hold places in vectors or tibbles, and R will attempt to perform calculations on NA values. It's very important to understand how R operations work on NA values. Suppose I ask R to add 2 plus NA. If I were to reframe this mathematical expression in words, I would be asking R, 2 plus some number I don't know equals what? The correct answer is, I don't know, because I don't know what that second part of the operation is. Any mathematical operation on a missing value should itself be missing, because it reflects that you don't know everything that's feeding into that calculation. As a result, NAs pass through most operations. For example, any math involving an NA is always going to result in an NA. Likewise, logical tests involving NA return NA instead of true or false. An important implication of this is if you test NA equal to NA, it does not return true. Why do you think it works this way? Remember that NA represents a missing value. If 2 data points are missing, can I tell if they're equal? Suppose I collect a survey from people that asks for their height. 2 people who respond to that survey, Charles Barkley and Spike Lee, I'll call them, don't answer. So I'll record their heights as NA. If I were to ask, is Charles Barkley the same height as Spike Lee? Should I get a true or a false? Given the information we have, we just don't know. The result of that logical test should be NA as well. We don't have enough information to say whether it's true or false. So this is why in R, if you perform logical tests on NAs, even if you're testing NA equal to NA, the result is always an NA. Let's look at some examples of this. Every mathematical operation involving an NA is going to result in an NA. If I were to take 2 and add it to NA, I get an NA. Likewise, logical tests involving missing data always give you an NA as well. If I test a number equal to an NA, again, I get an NA. The same thing with text. And importantly, the same thing with the piece of text NA equal to the missing value NA. NA is also not equal to itself, but it's also not equal to itself as well. As you can see, every logical test involving an NA will always return NA. This might not be your intended behavior, and in fact, looking at the code window, RStudio actually warns you when you try and test if things are equal to NA, that you should use this function is.NA to check for NAs instead of using the equality test. Where are we going to see NA values? These are going to occur when we have missing or blank entries in a data file. Also, if you attempt to coerce a variable to a new data type where R can't actually do that. Dealing with NA values is an important part of data wrangling. There's a couple of ways to deal with them. You can exclude them from your analyses, you can impute them, But whatever you do, you should document it. We'll talk about these strategies more in the next video. So as I showed before, NA equal to NA does not return true. So what do you need to do if you'd like to detect NA values? RStudio gave us a hint. There is a function for detecting NA values called is.na. It's going to return true if the argument is NA, and it's going to return false if the argument is something else. What if I'm looking for non-missing values? If that's the case, I can test for is NA equal to false. In those cases, NA values will return false, and non-missing values will return true. Those of you who are good at logical tests will realize that this is exactly the same as using the not operator, which is the exclamation point. So if you use an exclamation point before is NA, you'll get the exact same result because you're saying not is NA. Let's test for some missing values. Remember, is.na will return true for missing values and returns false for non-missing values. In that case, 5 is not missing, so I get a false. The text NA is non-missing as well, so I get a false. If I want a true for values that are not NA, I can test is NA equal to false. Here you can see that gives me a false. This is exactly the same as using the not operator, which is the exclamation point before my logical expression. This works the same with non-missing data as well. Now that you understand how R deals with missing data in operations and how to test for missing values, you can start to think about processing missing values when you're wrangling data, which we'll cover in the next video. Before we do that, let's take a look at some data with missing values. I've prepared a special data file, weatherwithnas.rds, that contains data we're familiar with, but I've replaced many of the values with NAs. I'll load that data. And let's take a look at it. Looking in the viewer, you can see many of the values of the temperature variables are missing. How could I take a look at observations where the minimum temperature is missing? Remember, the is.na function returns true when the value is missing, so I can use the filter verb and supplies the argument is.na on the minimum temperature. This will limit my Tibble to only observations where that variable is missing. As you can see here, there are 9 observations where minimum temp.f is missing. There are missing values in several of the other variables as well. dplyr provides more advanced methods for dealing with missing values that we'll cover in the next video.